is a software environmentalist and CEO of Think.com. Think is a combination of two different words that he put together to make it sound oh so nice. Feel and think is where he works with an amazing team to make the insights of a system explainable. And much of the work is embodied in Glamorous Toolkit, a novel environment that enables Moldable Development. Moldable Development. It's so nice to have you on this meetup, Tudor. I can't wait to chat with you about this Moldable Development. About this Moldable Development. Welcome to the show. Welcome everyone
Hello.
who's joining us for the podcast slash meetup slash videocast, whatever you want to call it these days. I am super excited to have Tudor with us. He is, as you heard, the CEO of Think, which is feel and think smashed together. And today we wanted to talk a lot about what he is doing when it comes to Glamorous Toolkit and this whole idea of the development and the modable development, really. So, Tudor, maybe it's good to start just by saying hello and hearing a bit of your background, how you came to be where you're at, and what got you into it.
Well, hello, and thank you very much for having me. So, how did we get here? We got here because of a strange idea that I had about 12 years ago or so. And it struck me as odd that I was writing my whatever paper on software engineering and reverse engineering. And then usually like the way we were starting those papers, we're saying, well, developers spend 50% of their time reading code. And so we had all this research and saying, how do we improve that amount of time in which they were reading code? And then at some point, it hit me that the oldest reference I knew about the topic was dating back to 1979, so like 40 years back. And then it's just, it was strange to me that like after decades of research, we were still having exactly the same problem in front of us. Right? And we were saying it's not good that developers spend all this amount of time. We should optimize it somehow. But then eventually they were still spending all this amount of time just reading code. And today they do exactly the same. So we have studies, very, very recent studies that show exactly that. And I also talked in the meantime with many, many developers, several thousands of them. And I asked them, do you agree that you spend 50% of your time reading code? And they say yes. And it's like, it's an interesting thing, because I asked them on the next question, and the next question is, when was the last time you talked about how you read code? So not talk about the code you read, but talk about how you do the reading. Mm-hmm. And isn't it like a strange question to ask? I mean, doesn't it feel a bit, it's not a typical surgical conversation, is it?
Yeah, so it's beyond code reviewing. It is
right. Code reviewing, right?
Yeah, because code reviewing is a whole different area.
Well,
it feels like
no, it's not different area. It's not a different area. But if you think about code reviewing, how do people do code review? They read code, right? They never challenge the reading part, right? And and that's interesting, because if you look at it, everything about software is data. So the reason we read code is not because we don't read code like we read, like a a book or like a novel, or like you would treat like a, I don't know, a metaphysics treaty or so, right? It's not a like if you don't read it with the same intent. Typically in software engineering, we read code with the specific intent of figuring out what to do next. Now that's decision making. So from this perspective, right, this time, this 50% or more of the time is actually spent on making decisions. So given that, also 50% or more is an interesting figure because that's the single largest expense we have. There's no larger than 50%. So, so if you want to optimize anything, right, if you take a system and you want to optimize it, what do? Well, you look for the largest thing that has never been optimized, because that's where your potential of order of magnitude lies, right? Right. That's what you're looking for. Like if you see a chunk that nobody touched for like a year, decades, or I don't know, wow, that's exciting, right? It's slow now, but it's exciting because we can optimize it, and that's exactly what code reading is, right? Because nobody talks about it, everybody is doing the default, and that's highly unoptimal. So why? So we don't read code because we want to read code. We read code because we want to make decisions. So reading is the way in which we gather information out of data. Now, reading also happens to be the most manual possible way in which we extract information out of data, right? So the whole point of, MLOps of this community is based on this idea that, we're going to build all these cool, super cool algorithms to get humans to teach machines to tell humans what interesting, knowledge is there in that data that no humans will ever see directly, right? Not in that size. So we build all of these things under this idea that there is lots of knowledge to uncover out of data, right? And there's the interesting thing about it is that we possess this ability, right? Like it's the people that create software possess this ability of transforming data problem into information problem, or ideally decision-making problems. But when it comes to software, right, when it comes to our own problem, what do? Well, we think that the best possible solution is to go and do the most manual possible way of doing things. And I think that we can do better than that. So long story short, that's the origin story of it. Everything is as a consequence of that.
Basically, you realized this, what, like a few years ago or 10 years ago, you said? 12 years ago.
Yeah. Mm-hmm.
And you've been on a mission since then to try and optimize it?
Yeah. So I was in academia and then left academia. And essentially over the last 12 years, that's pretty much what I've been doing. And 6 years ago, we started Think. And Think is pretty much a vehicle of funding the work. We think that the way we reason about existing systems is not only there's a very large amount of waste, but it's also a very large it represents an economic problem and an economic opportunity. So our goal is to educate people as to how else software could be created and approached. And so so that's this one along the way I did consulting, and then I actually took a job in the ugliest system that I could find in my consulting work, and because I wanted to be able to live with the consequences of these ideas. So I led the development for 3.5 years in that system, and then it worked. And so then we started Think, and here we are.
So basically, you just wanted to make sure that what you were preaching wasn't snake oil, and it actually had something that was actionable and useful behind it.
Well, yeah. So many of us at Think are researchers, and at least we also are organized internally as a research group. So, which means, and it's so easy to get convinced of an idea and to self-validate yourself, but you're also very biased. So at the very least, we had to do some homework by exposing ourselves to funny situations that were outside of our control. So that's part of that. There's also what we are doing at Think. At Think, we fund ourselves through consulting, and every consulting project we do rather strange projects. We typically solve problems that others say are not solvable. And for example, we look at large legacy systems and say, how do we tell people what they should do about it? Like, how do you migrate it to whatever a new system, for example, or how to evaluate whether you should migrate, or what's the path, or so on. And this one, very often in the presence of maybe the original team maybe is not there, or if it's there, they don't know exactly what the system is anymore. So basically competing with, let's say, a decade, we have maybe 1 or 2 months to start competing with a decade of development experience in that system, and we're able to produce some value there. But so that's on the commercial side. But all of those experiments are actually, they show that it's possible to go into a system and reason about it without actually having all of these, without relying on what everybody else today rely on. And that's also a validation. But we're very much interested in getting other people to start, or to adopt these techniques and start validating themselves. And this is why pretty much most of the work we do, we create is free and open source, and because we want to invite people to learn from our initial steps. And I'm very convinced that this is a very large problem. We're talking about 50% of the development budget. 50% of the development budget. That's a huge amount of budget. And you see, for example, if you look at DevOps, if you go back 12 years, it wasn't really a subject. This is when it became kind of a subject of conversation. The thing that, like MLOps, for example, or the kinds of things that you talk about today would have simply not been conceivable without DevOps having been a conversation already. Mm-hmm. So every time we, as an industry, deem a subject an important subject, and we say we have to improve on this, we get to improve on it dramatically. And the kinds of things that we create are unpredictable, before we start the conversation. So I'm very convinced that we have the beginning of that conversation. We can show why it's a worthwhile conversation, but it's not the end of it.
Well, so it's interesting. And I know that you mentioned you are going to show us some stuff and give us a bit of some live coding later on. But before we talk about that, or before we jump into it, the value prop is very clear, right? Like, the time that we're wasting while reading code is too much time. It doesn't need to be that much. And why have we not ever asked the question, is there a more optimal way of doing this? And so if I'm understanding this correctly, it doesn't matter if you're a front-end engineer, back-end engineer, if you're doing MLOps, you're doing SRE, whatever you're doing, if you're reading code and your head is in GitHub, then you could be doing this better, and you don't need to be spending as much time doing it. And do you think that, so here, I guess, is the main question that's going through my head is, could this not be solved by just writing better code, or like commenting the code better?
No, it couldn't. So because you also mentioned, but it's a very good question. And in fact, that's exactly the idea that we had for so long, right? If you think about clean code, right? That's like a phrase. There is this idea that there is a perfect state of code that will make it instantaneously understandable. First, we don't seem to be able to do that. But the other thing is that it's possible to give the same piece of code to two different people and yield dramatically different results, both in speed and accuracy. So if this is the case, it must be that it cannot be just depending on the code. That's the first thing, right? The second thing is that, right, there's an interesting, so you mentioned that my title is software environmentalism behind that of being the CEO. So it's a term I coined, and it basically is based on another realization or another observation. And the other observation is that the body of software grows exponentially year over, so it grows super linearly year over year, right? But at the same time, we are unable to recycle all systems. Like, so you see, for example, like right when the pandemic started, you could see there were all of these unemployment systems in the US, right? For example, the government of New Jersey came, on TV or on social media saying that they are looking for COBOL programmers because their system is crashing because of all of these amount of things, which there's a whole interesting story there, but the story doesn't really matter. What matters is that there is a system there. And the fact that the technology was usable in that political context and so on, it's very, very interesting. Because it has never been obvious until that point, at least not to that person, right? There's never a priority. Oh, it's COBOL, like who cares, right? It's just a technology, it should work. But apparently it doesn't. And it's not because people don't want to change it. It's not because they don't want to change it, it's because they can't. And that's a very important thing. And we tried for so long to get the code clean and do the best modularization possible. And it just doesn't seem to work. It's not enough. And all of those things are very important things, but we still spend all of this amount of time reading. So what we can do is treat our systems as data, because they are all very, very qualified data. All of these ML things, right, is a lot of it is done or is applied on top of unstructured data or poorly structured data or right? But software is incredibly structured data. We don't even need machine learning. You don't need that, the craziness on top, right? We can simply leverage the structure that we have, and we would be an order of magnitude better than we are today with very little investment. That's the interesting thing. So writing better software or trying to write better software will not solve the problem of how you're going to go and understand it. Because of scale.
I see what you're meaning completely. And so I guess I'm trying to wrap my head around this, and it would probably be good if you can dive into some of this live coding that you mentioned, just to show me, like, what exactly are you proposing? What is the idea here that that is going to save us all this time, right? And make sure that we don't have to spend so much time reading, and we can spend more of it doing the important stuff.
So here's an example. I mean, here's a little tour. So the specific technology that we create is called Glamorous Toolkit. It's an environment. You can think of it as a development environment. We call it a Moldable Development environment. The details don't matter at this point, but basically that's our company. But here are 6 different objects. So like if you think about, our systems are made of a ton of details, but if you look at the cells in this system, right, they're either you look at functions or you look at objects. So it's one of these, depending on how you perceive it. But if you look at the state, these are objects. So here I have 6 inspectors on 6 different objects. Okay. Now, if you look at these ones, just these objects, right? It's actually this is how all objects in the world are pretty much shown on inspectors, right? So the inspector is the tool that shows you the inside of the object. So you can see these kinds of variables and values, pretty much, right? And maybe you can expand them, have a tree or something like this. But if you take, if I ask you, do you know if these objects are really different, or how they are different? Now you're going to have a hard time, right? It's a simple question, right? We're not talking about a large problem here. We're talking about a tiny problem. And the question is, how long does it take until you figure out whether or not they're different, right? And of course, for example, here we see, look, this is a larger state that I have here. So there are more variables. And then here I have 3, 3, 3. So are they kind of the same or not? For example, here I can see path file system, file system. So maybe they are the same. I don't know from here, but let's do something else. If I now switch the views, I take exactly those objects, and the only thing I only change this thin layer through which I look, because that's the interesting thing. There's nothing in a system that can be experienced directly. Everything we experience in a system goes through a tool. Everything. There's always a projection in between. And I'm up to now, because we never talk about it, we took this tool, we took it for granted, right? So what do I mean by for granted? It means that all tools, all inspectors today show you exactly this view, right? Which is nice because it's generic, it's applicable to all possible objects. And that's exactly why it's uninteresting, right? It can be like the default thing, but it's just totally uninteresting, right? Because if I change it like this, now all of a sudden you're not thinking in the same way. We've changed how we think about the problem completely, right? So we can say, okay, that looks like a fraction, that looks like a folder, right? That looks like a picture, right? They're both the pointers into the file system. So they will be, the objects are going to be very similar, but they are fundamentally different here, right? And that looks like some sort of a Bezier curve. That looks like some sort of an algorithm. That looks like some sort of a data structure over here. And that's the idea. That's the simple thing. The thing here is that the idea is that there is, if we control this layer, if this layer that translates what we're looking at is under our control, then we can start approaching everything around us, which is, by the way, that's where the original idea of a personal computing comes from, right? We just went astray into this area of apps and very isolated data silos that we it's very hard for us now to grasp what people 50 years ago already knew, right? I don't know why we forgot it, but we did. So that's the idea of moldable development. We are saying there is no single perspective, there's no single dominant perspective on anything in software, and that the shape of tools is actually essential in software engineering. So what we're doing is we're going to create, for every single problem we're going to have, we're going to create a perspective that matches what we're looking for. So here, for example, are this is how our inspectors look like. It looks like kind of like this, right? So this is the raw view. This is the items view. This is the path, right? So notice how this is a picture. So it has a picture view over here, but it also has a path, because they are both pointers to the file system, so it kind of makes sense, right? So but this one also has a hex, for example, because why not, right? And then the same thing happens here. So this is actually a look inside an editor, like inside the text in an editor. So we can see there's a string. We can see the data structure behind let's just call it rope in this case, right? We can see the rendering of it. We can even interact with it here. But so that's the core idea. Okay, so let's apply this one to something that is maybe more interesting. So what you're seeing now here is we are inside the environment, right? So I gave you a presentation in the environment, and now we're switching to something that you might think of it like a notebook, right? But it's just not just a notebook, but also like a wiki here. So I have here, playing with JavaScript, so I can go to this page, so I can, see the connections between them, and all of a sudden I can say, okay, I have here a JavaScript system, and if I'm inspecting this, I see, the items, so I can go and navigate through those, and I'm going to see here, these JavaScript, and if I look at the JavaScript, I can find JavaScript. So right now you are actually in an inspector up to now. This is an inspector. This is not a file browser, but if you look at it like this, kind of looks like what is this actually? Is this like a notebook? Is it a file browser, inspector? What is it? And that's another thing. We got used to naming our tools. And so usually what we say is that if you can enumerate and name your tools, you probably have way too few of them. So instead, right, we want an environment where tools come to us and they present themselves when they're interesting. So let's do something of interest, maybe. So let's say, for example, here I see, okay, I have a package.json, okay? And for example, here I can see, okay, look at these are the dependencies, right? This is how the dependencies are defined in this JSON. The question here is, how many dependencies do I have, and how many of them are not going to React Native? So I already know that this is a React Native application, so I'm not interested in those dependencies that go to React Native, right? So it's simple kind of questions. You can apply this to all sorts of other systems. But the question is, how do we go about doing this? And I mean, there are not that many of them. So maybe I could, I don't know, select something here. But it's kind of, like maybe I could see how many React Native are there in this file. But if I do that, I'll also be probably looking for other places. I might be hitting something else. So it's kind of hard, right? If I want to approach it like a text problem.
Mm-hmm.
But wait, this is not a text problem because this is a JSON problem. So if it's a JSON problem, I can just take a JSON parser, right? And I can say, well, actually, I just want to parse the content. So self here, I actually have a notebook here in the presence of this object. So self is going to be this object. And I'm going to say self contents. And if I'm doing self contents and I'm inspecting that one, that's a string. Okay. So now if I'm doing, I have a JSON, I'm going to parse it. And now I get a dictionary back, right? So like a map in other languages. So, right. And I say, okay, look here, dependencies is right there. So so I can say now, okay, let's actually query that. So dependencies, I can say, okay, that's the dictionary of dependencies. And maybe actually, let's just take the key values, right? So we don't want to see the dictionary, we want an array with key values. So now this is the key, this is the value. And of course, if I have that, I can just simply select, and I'm going to, select those for which the key begins with React Native, right? And now I can say, okay, look, there are 21 of them, right? And then if I'm going to reject those, then I have 19. Boom, I have my answer. So what just happened here, right? I had a question, and then I asked myself, what is the most interesting tool I need to answer that question? And then I said, this would be an interesting tool. Do I have that tool? No. If I don't have it, I'm going to build it. That's Moldable Development. That's it. It's that simple. I'm just going to refuse to scroll. I'm simply going to refuse to scroll through any piece of text. Because when I scroll through text, I will say my eyes are the data mining tool. They just don't work like that. They are very good at defining patterns. So I did actually scroll a little bit, but just to orient myself, not to do the number crunching. That's the difference. That's where the largest part of the reading is actually being wasted. That's where the waste is. And we can transform pretty much any software engineering problem that we have faced for the last decade. We are pretty much approaching it like this. And the whole Glamorous Toolkit as an environment was built with this idea in mind. So, and then from here, we can build more. So, but go ahead.
I understand the idea of sorry, the word's not coming out now.
Moldable.
Moldable, that's it. And this is really interactive. It really feels like such an upgrade. And wow, I want to see more. Yeah, keep going. This is just so cool.
So, we're still in the area of, like some sort of architecture, figuring a system out, right? Just figuring a structure out at the moment. That was just doing static browsing of the code, right? That's the area we're in. So let's say I know I have in this case, a React Native system. So because I know that, I actually created a little model here. And when I say model, I don't mean the machine learning model. I just mean a plain old normal model, right? Just like a data structure, basically. I parsed that thing and I created it. Like normally, first thing you do when you get a JSON, you get a tree, right? That's what you get. That's the JSON. And then the next thing you're going to do is let's transform it into a graph. That's what typically happens, right? It's going to create the links and resolve the links and so on. So that's kind of the things you have exactly here. So now I have here a database, an object-oriented database about my system. So now I can start querying it exactly in the same way I've done before. I'm going to go and inspect those, and I'm going to start querying it. So so one of the things, I'm not going to go too much in this, but one of the things that we noticed, the reason we built this was because we were playing with the mobile application using React Native. And then like we were not even 2 weeks into the system. And we immediately got into this problem of cyclic dependencies. So between the components in React, right? Like if you know React, that you have components, you can define how they embed each other, and then you go into those kinds of issues. So and then we looked at, so then surely we're not the only ones that have hit this problem. We just were doing it for 2 weeks and we got into this. We were new to React Native. And indeed, yes, lots of people are getting into that problem, but there are hardly any tools, right? And we said, well, how is that possible? So what do we do every time we don't have the appropriate tool? We're going to stop, we're going to build the tool. So we built a tool. So here's, we have the, we built a tool that could extract the actual, only the components. So here, if I click on it, I look at the component, I can look at the source code of it. So I can see, oh, look, this is an input component over here. It's defined like I don't know how. And it does things, right? I can browse through those, like an option button, a center container. I don't know what these are, right? And then here, for example, I can see how this one is implemented basically like this. But now we wanted to find out all these dependencies. So we built this view, right? And that view now, what is this view? Well, this is a, for example, a render button over here that it says that it embeds a button. So if I now click on the render button, I should see, okay, this is render button. And indeed, it embeds a button, right? So this is how we found our cycle, right? It's not this one over here. It's not the same case study, but that's the view that we use to sign the cycle. And that was it. That's how we approach these problems. Now, what did we see here, right? First of all, we see that the editor always comes at the end. The editor is never the first thing you see, right? Because, and that's an interesting thing, right? The question is, why do people, right? If this is such a, so costly, such a pervasive problem, why do people not talk about it? Now, it's very interesting to see the behavior of people, how the behavior of people correlates with the interface that they are exposed to. Because if you go back to Marshall McLuhan, the previous century, but you have this idea of that the tools that we create end up influencing the way we think, right? So when the only thing you have at your disposal is a giant text editor, because that's, if you take a screenshot of any developer desktop, you're going to see a large editor in front of you, like 80% maybe of the screen real estate is going to be spent, is going to be taken over by a giant text editor. And the interesting thing about it is that you can do this as an exercise. Take 2 screenshots of arbitrary systems, doesn't matter, right? And then stay like 1 meter away from the screenshot. You cannot tell them apart, right? Because the tool is rigid. You always see it exactly in the same form, right? But there is such a power in the form, right? Because the only thing I've done here, as I said, I don't want a list. I want this view. And all of a sudden, it solves that problem. For some other problem, this dependency view, totally not interesting. I need another one. That's the thing, right? So if you think of all your tools, they will all have a hard-coded layout, right? You have the tree on the left and the editor on the right. And that's pretty much what you're seeing all the time. And people are trying to smash or mash, like somehow fit into that rigid tool their problems. And that tool will just not scale beyond the 50 lines that you're being shown at the time. So what people do is that they just use reading as their way, right? So the most advanced types of things are doing greps, right? Which is what is treating source code as if it's an unstructured natural language, which is not, right? So there's a lot of opportunity.
Yeah, I love this. And there's a question coming through from Mike. I'm gonna allow Mike to talk. Just let's see if he is able to chat. I think you got to unmute yourself, Mike, if you want to ask that question.
But I can see the question here, Mike. If you want to follow up I'm reading it now. Is the example that I'm showing here, this is a system called Zooniverse, which is based on React Native. If you would have a system implemented on top of Angular, would this idea be equally applicable? Of course it is, because this is not a tool for React Native. So just to maybe get that point across, let's look at the Ruby on Rails system, right? Totally different. Like we can't even say that they are in the same, right? Like this one is on the server side. So people will say, okay, maybe this only works for the client side, or maybe it works for. We somehow got tricked into this idea that software fits in labeled boxes, right? That the thing about the like the server side and the client side, they obey different laws of nature, and that the way we log and the way we debug is totally different. Or the way you're going to edit a JSON is really different than the way you're going to edit your code, or any of that. And that's wrong. We shouldn't think like that. So there's if you go a step further, right, and we say, okay, these are just some structure defining software, then all of a sudden you're no longer confined to, is this a JavaScript tool, right? Because we literally didn't have the JavaScript logic. We built it. We constructed the whole logic of constructing that model just for that purpose of that project. So anyway, so here's a Ruby system, and this Ruby system has another. So I'm going to do the same thing. I'm going to import. I'm going to create the model from all of these sources. But in this case, so before, I actually didn't look at JavaScript. I looked at the components in React Native. So a high-level construct that you have to understand if you look at the framework, right? The same thing happens here. So if you're going to look at the Ruby on Rails application and you're just going to look at the Ruby code, you're going to miss pretty much everything that is interesting about it, because there's so much there's so much happening in the framework, right? And there are conventions that are happening there. If you're not aware of them, you just won't know it. I don't know why this one now takes so long. It shouldn't have taken so long.
But so this is, just to reiterate that idea, is that it's really agnostic. Like I could do this in Go, we could do this in Python, we can do this in Ruby. Doesn't matter, right?
It doesn't matter, yeah. I don't know exactly what happened here. Let's actually look at another one. So in this case, we can look at we can look at I don't have this one anymore. So yeah, this is it's a simple. I'm not going to show this demo anymore. Let's switch to another one.
Yeah, and I think we all know, considering we've all done live demos, these things happen. We got to pray to the demo gods that you get the perfect demo.
So if you look at the essence of moldable development, is kind of like this, right? If you think about development, people just think about creating, right? That's what development means. It's typically associated with the act of building something that didn't exist before, right? But then you have all this amount of time that you spend, which is not on reading, so not on building, but you're doing something else, which is actually this decision making. And up to now, we just look maybe at the small scale, maybe a file or so, but sometimes you want to look at a larger scale. And where we talk about architecture or we talk about business, At the end of the day, people want to be able to make decisions about the inside of systems, right? So especially if you go towards business, they make decisions about what they see, how they experience the system from the outside, right? Not from the inside. That thing doesn't work there so well. So there's a loss of opportunity that happens because of that, right? So if you think about DevOps, right? Before DevOps, you had release, typically people would release once a year or maybe twice a year if they would be aggressive, right? And then you go to in a DevOps world where you release, 10 times per day, or I don't know, more than that. So the difference here is not just, the cost of deployment is smaller now. The difference is that now the whole business can think completely differently because that cost dropped to almost zero. Because the cost of a single deployment dropped to almost zero, the consequence is not, we just saved some money. The consequence is, we can make a lot more money because we can now think differently. So that feedback loop brings with it a whole new way of leveraging what you have in front of you. So in the same thing, this is another feedback loop that you're seeing here. So if people can only reason about the system from the outside, right, you're going to wait until that outside is happening. So let's say maybe once an iteration when you're going to get a demo, right? So that's like what, once every week or so. But why not 10 times per day, right? And what would happen if the CEO of the company would be able to reason about, like, you could explain to the CEO what is happening in this part of the business that he just asked you a question about, right? What would that mean, right? So that's the kind of feedback loop that we are bringing with this idea, with moldable development, right? So the way this works, you always start with the question, right? Then you apply an analysis, you interpret, you feel confident, you make a decision. Now, if you look at this, right, this is not that different from the scientific method, from what people do when they do data science, because that's exactly it. There's no difference about that, right? You have a question about lots of things you don't know about, or worse, you think you know about, because that's the worst thing, right? You think you know your system, but the system has changed many times because you cannot keep up. You cannot read hundreds of thousands of lines to know what is the impact of that little change that just happened 10 minutes ago, right? Made by somebody else. You don't know. And when those changes accumulate over a significant amount of time, then all of a sudden your understanding is going to drift from the reality. And that's the problem. So this is the scientific method. This is not really new. But the essence here is what moldable development is about. We're going to stop and ask, for this specific question, do I have an appropriate tool? And if I don't have it, that's the key question to ask here. And if I don't have it, I'm going to build it.
Well, and this goes back to something that I was talking to you before about, is how can we make sure to not repeat ourselves, right? And it makes total sense now that I've seen this. Before, when I was talking to you, I didn't really understand how this whole customization for each project worked without having to do a lot of legwork. But now it's absolutely clear, because you're taking something and you're able to visualize and see where you have things that are working. And then if you don't have something that's working, how can you put it in and make something?
Exactly, right? And so what we have done is, right, the key here is, how much does this cost, right? Because if this one costs you days to build a tool, that for each of those tools, it's just going to be, it's too much. It's never going to work, right? But if it costs you minutes, then all of a sudden, boom, you're in a different world, right? We saw, for example, similar things we saw with testing. When testing became so cheap that basically the cost of a test didn't really matter, right? The only thing that started to matter was, what did you put in a test? Then all of a sudden it changed the landscape. It's that little change that looks, so I had a testing tool before, I have a testing tool now. The distinction is, this one is like very, very cheap. It's 10 times cheaper then all of a sudden you're not in the same place. We saw the same thing, for example, with apps on the phone. So the app on a phone is many times cheaper than an app on a desktop. For example, it was when it was introduced, and that people say, well, yeah, we had tools before, we had apps before, and nothing new about this. But that economic model made it possible for a single person to actually have a possibility of having a viable, a viable model of creating and targeting a super tiny niche. And that's why, right, we see this phenomenon where you see that the vast majority of apps are actually not used by the vast majority of people, which is exactly what makes them interesting. Because now you have the possibility of target, because of that small cost. There's lots to it, but at least in theory, you have the possibility of targeting small niches just because now the cost has dramatically diminished, right? Whether this works in practice, with all the other pricing models that exist today and all those challenges, it's a whole different area. But the principle remains, right? When something drops an order of magnitude or more, beware, like the interesting thing that happens is on how you're going to think in that presence, right? Because like, for example, with DevOps, if you're going to introduce automation of deployment in a system, but then don't change the way you're going to work, you will not gain a lot, right? That's the thing, right? But if you change the way you're going to work, then you can leverage it significantly. So so let's take a look at
I just wanted to mention too, this gives you so much visibility into what you're looking at, and I understand the value prop there. It's so clear on when you were describing it at the beginning to me, like, yes, reading code is very, very inefficient. I was having a hard time understanding what is the better way and why have we not done it already, right? Because it's like, this is code, it's kind of in our blood almost. Reading code is something that you just have to put in the sweat and tears and reading it.
Right.
And here, this is so much more visual, and you're able to get directly to the point without having to sift through, like you said earlier, our eyes become the data miners, and that is really inefficient. And so I completely understand this.
So let's take it a step further, right? So we looked a little bit on how we browse, structure of code, but let's take a look at something that maybe is closer to the MLOps as a domain. So pipelines, right? So some sort of pipelines, right? We didn't have direct exposure to MLOps specifically until now, but let's look at something that is somewhat similar. So let's say our deployment pipeline. So whenever we go from a single commit to deploying, what happens? So we're using Jenkins for this, right? Now, typically when people look at the status of their build, what do? Well, they leave this. What's the name of this tool that people see? Typically, like developers see. What do they call it? It's not the editor, right? It's the integrated IDE, right?
Yeah.
But the I in IDE stands for integrated, right? So, which also means that every time you leave, the I has failed, because there's, right? That's the definition of it. So, so now people go to Jenkins blah blah blah, and then you use the web interface that is there, and you're going to use exactly the same web interface that everybody else is using. And that's like an interesting, it's interesting by default, but it's totally not interesting in the context of your project. So, so what we are seeing here is exactly this, right? And we're bringing it into our little place, right? Because we want to be able to manipulate and do our like what is meaningful for us. So this is the list that is meaningful for us. This is what we want to look at, right? So I can see, okay, look, for example, there's a failure over here. So what does this mean? Oh, look, looks like this step over here has failed. So maybe we can take a look at the stages map. So, right, so in order to do this, actually, to find out how to visualize your map of your pipeline, you have to go to another. You typically install some sort of plugin and in there, and then if that one is compatible or not, and then it goes like this. So, so here it is, right? This is our pipeline now, right? But notice how this is nothing but just some object representing a pipeline run, right? And I have a view over it, and that's it. that's how the interface. This is the interface that's good enough for me here. So now I can say, okay, it's actually the last step. Great. So what happens next, right? What happens next is I'm going to want to click on that thing, and I want to see more, right? So now I'm going to say, okay, look here, I have the steps, and this is this is not rehearsed. This is just I literally took my our development, our Jenkins that looks like that is how it looks like today. So I see, okay, steps. But if I expand that one over here, I actually get to see the console just for that step, right? And look, there's some sort of highlighting here. This is gray, right? And if I'm going through that, I can see, oh, look, there are some red things over there, right? Now, these red things, these are our rules, just for our project. They're not for everybody's project, right? And we have just, enhanced the way we read that log. And that log is not structured, but it's still structured enough that you can highlight things about it. But then you can take a step further, because the question is, how are you going to do, all of these things? So if I'm now clicking on this one, if I alt click on this view, I actually get the sources. That's the source code that is in here. So actually, let's go and just look into this specific. I have dived into just this one node. I'm opening it here. This is the console view. So I'm looking at that one. That's the source code of the console view. And I can see, okay, look, this is like a text editor and has a styler over here. So I'm going to now browse the styler. I can see, look, I'm now into a browser of a styler. So I'm browsing the code. And in this one here somewhere, there's going to be some private style. And these are some methods over here that actually literally are the ones that are responsible for highlighting these parts, right? So if I take our little example over here, I can see it has something with square bracket 0m over here, probably one of these, but I don't know which one they are. So I can just do it in place. I can just take this one, and expanding the text in code. So now I have an editor in an editor, because why not? And then, of course, here you can say, well, I have here, this is the error background color. So I can look at that one. It looks like it's red. And I can go and change this one if I want to. And it's right here. So let's actually do that. Color blue. And if I save this, I think if we're lucky, if I found the right error to highlight. No, it was not the right one, but this one would have worked. So it would have highlighted that one if this would have been the one that I matched. But basically that's the idea, right? You have a tool, you look at it, and then you go and you're going to enhance it. So the next thing would also work, right? So if now we say, oh, I really would like to find all of these 0.3 and highlight those, then I can go and extend the tool right in place and get the feedback that I'm interested in. And then I publish it for others to use in the team. But it doesn't have to be reusable outside of our scope, because the cost is so dramatically low that I can just build it for us, right? I don't have to think about reuse before I start building. I can reuse it afterwards if I want to. But what if it's profitable to use a tool the first time, only the first time? Then you can throw it away too, right? So totally new workflow.
Wow. Yeah, this is very, very different than anything I've ever seen. And I would love to hear if anyone in here or in the comments, if you're watching this in the future, has seen anything or played with anything like this. we're approaching the hour mark, and we got to go then. I want to be respectful of your time. Just so everyone knows, they can get a hold of this and start playing around with it. Where?
They should go at gtoolkit.com, and they'll find it there. So I'm going to share this one briefly.
And we'll link to that in the description if you're watching in the future.
So this is the environment. It's free and open source. And again, like, it's an environment that shows how moldable development works. We want you to go and get your hands dirty. It has a whole notebook technology inside. As you could see, it has a whole knowledge management system inside. You can even, you'll even be able to tweet from it if you want to. So, and our company is called Think, and you can find us at think.com.
Thank you so much, Tudor. This was truly amazing. I know it wasn't specific MLOps stuff, but this expands over things that machine learning engineers and people who are knee deep in MLOps are doing on the day-to-day basis. And I hope a lot of people see this and they pick up this tool, and it saves them a ton of time. And it also gives them insights. Like, what I'm super excited about with this is the insights that you're able to get at such a rapid pace, right? Like, you can just click through and go deeper and deeper down the rabbit hole.
Yeah. And I noticed, as a brief last word, so there was a couple of sessions back, a couple of meetups back, there was a demo of a whole pipeline of machine learning, going from nothing to deploying an actual machine learning, right? So what you will notice during that demo, which is, it's really fascinating to watch, is that you're going to go through a half a dozen different tools and interfaces.
Yeah.
And your mental model will have to switch. Like, you have a single thing you want to build, but you'll be forced to now frame it like this and like that, depending on what the tool would want you to do.
Yeah.
Right. And there's a whole lot of missed opportunity that happens right there. Right now, there are a lot of implications. There are a lot of details that come from here. Just like with, as I said, with DevOps, you can see, oh, look, the deployment is faster, but the really interesting things happen way after that. The same thing with moldable development. We didn't go into how you can explain a domain. For example, another problem in machine learning is explaining the explainability of the algorithms, right? For example, how do you deal with bias and so on? The problem there, though, is that this problem is actually not unique to machine learning, because everybody wants to know what is inside a software system. But in order to build that, to get to the bottom of the machine learning, and we have to be, as a society, we have to be able to explain the machine learning algorithms. We have to have a solid base. If you're not able to explain simpler constructs, what kind of chance will we have to explain the machine learning part, right? Yeah. These are not distinct kind of spaces. These are similar, there's very, very similar spaces. And they can be approached with an interesting, or with a unified idea. And that's basically what moldable development is. I
love it. I'm so excited. And I thank you so much for coming on here. And hopefully everyone else learned something that they can take home. Go check out gtoolkit.com. Is that it? gtoolkit.com. Download this product and start playing around with it. I'm going to start playing around with it. It looks fascinating. So thank you again, Tudor. Well, we'll see you later, man. This has been awesome.
Thank you. Bye.